Alright, I'm going to do day 2, Unit 9, day 2 notes today. I'm going to start from the section that says warm up here. Even if usually you guys get to do the warm up that's in the classroom. But the reason I want to do it here is because a lot of the content in this one is kind of new. It's not from what we did last class. So I just wanted to make sure I go over this before the notes. So it says fill in the blank, refer to the diagram when necessary. And the first one is an arc as a part of a circle. So it's kind of also help you to define some of the words we're going to be using today for the lesson. And I think the reason we have this here is because you guys should already know some of the vocabulary we're going to be using here, right? So an arc is part of a circle. The entire circle is going to be 360, right? I'm sure you guys know this as a whole. When the degree measure of a circle, any kind of circle, big, small, or whatever, it's always going to be 360 degree. So when we're talking about this arc, though, we can either classify them as minor arcs, major arcs, or sometimes we call them semicircle arcs, which the word itself kind of tells you. What is a minor arc? It has a less than 180 degree. So you can kind of see in this case from B to C is my diameter, right? If I can draw a straight line, that's my diameter. So anything on top of BC is going to be 180, but anything that is less than that degree is going to be called a minor arc. And another characteristics of a minor arc is how do we name it? So, and sometimes you just wanted to say, let's say AB, right? AB is right here. But which direction you guys are going? AB this direction, or if I go from A all the way to the other side to B direction, is that which one? It's kind of hard to tell. That's why whenever we name a minor arc, we use only two letters. Okay, we use its endpoints, and we're only going to use 2 points. Okay, um, or two letters, I guess that's what something you can say. So I can name it as AB, right? And I can put an arc right here. That's a minor arc. Or I can name this arc here as AC. Two letters, and this is also a minor arc. Okay, and when it comes to major arc, it has to be more than 180 degree, and it's named by its endpoint and one other point on the arc. So major arc has to be more than 180. So in this case, if I kind of erase this part, you can kind of tell, BC, the line BC is going to be your semicircle. So I have to pick something that is going to be more than 180, right? So I have to, if you want it, we can start from B, we can go C, but I have to add one more, which is A. So BCA is major arc, or yeah, more than 180 degree, or I can do ABC. A, B, C. That's also a major arc. So if you can see, A start from here, B, and we go around C. So that's going to be a major arc. And a semicircle, so you put semicircle here. It's kind of hard to write. Is an arc with exactly 180 degree, and name two of the endpoints. And you can include one of the middle. So if I say BC, either direction, it's going to be half a circle. But if you put, if there's a letter right here, let's say that's E, I can also use BEC to show you which direction. But either ways, it's still going to be 180 degree. So it does, the semicircle is always 180 degree. So it doesn't really matter which way you name it. All right, the second set of problems we want to do is going to be find the value of each. And then remember, we're going to talk about this more. See, when it talks about m here, I can't just keep on touching it with my hand. So m is here, which is the measure. It's talking about what is AB is going to be. Okay, like which is this right here. So what would be the degree measure of m? Okay, so you know whole circle is 360. So if I'm cutting it, see this is 90 degree. So the degree measure is going to be 90 degree here. Okay, and when it comes to the diameter, remember the relationship is d is equals to 2 times the radius. So what is the radius in this case? It's 4. So 2 times 4 is going to be 8. Very good. Circumference of a circle. Last class, I think the last problem has that C equals 2 pi r. And you don't have to worry about memorizing this formula because it'll be given to you. So in this case, the radius is, or we can do pi d. I can also do pi d since we already saw for the d. So circumference of circle Q is 8 pi. Okay, area of the circle is pi radius squared. I already know the radius is 4. 4 squared is 16. So the answer would be 16 pi. When it comes to the length of the semicircle, I know the whole length is what? 8, right? The whole length of the whole thing is 8. If I'm looking for a semicircle, then I have to do 8 pi and what? Divided by 2, right? Because I'm looking for half. So this is going to be 4 pi. When we're talking about the arc length of AB, this is 1/4 of it, right? This is 1/4 of the whole thing. So what's 1/4 of 8? Perfect, 2 pi. Okay, so that's what you guys need to remember. So this is basically what we're going to be talking about in this section, is how can you tell the difference, or what does it mean to have an arc length and arc measure. They both have arc, that's part of the circle, but what is an arc length? It means measurement in centimeter, in inch, meter, yardstick, whatever you want to do. But when it comes to an arc measure, we're talking about the degree measure of that arc. Okay, that's what we're talking about. So the formula, as we just said, is circumference of a circle is 2 pi r, right? Or I can use pi d. That is the circumference of a circle. When I'm trying to find an arc length, all right, so I just wrote down a couple of things just to make sure you guys have it. So arc length, I know we put it here in the note that says it's a measurement in inch and in centimeter or meter. So that's something that you use a string, like you can, it's hard to use, a centimeter, like a ruler, and then trying to measure the circle, but you can just measure it with the string and then put it on the ruler and you can find it. But when it comes to arc measure, we're talking about a protractor. What degree is this arc? Okay, so circumference is 2 pi r or pi d, as we said earlier. And then when we're trying to find the arc length, can be calculated as a proportion of a circle to the length of the total. So I know for any arc measure, it would have a length. I don't know what that length is, but I know when it's a 360 degree, the circumference is going to be c, or 2 pi r here. So it depending on how you guys want to write the formula, sometimes I write it as c, or I can just put, okay, what is c? C is going to be 2 pi r, right? So you can put 2 pi r here. So you can put 2 pi radius. Okay, that's what we have. So let's see if we can do couple of problems with this. So the first one, so I'm just going to still keep this. Find the length of AB. So I'm trying to find what is the length of AB. Okay. Do I know the degree measure of AB? Yes, I do, right? Which is, I don't know, is it 80 or 60? So my eye said right now sees 80. What would be the measure of the arc AB when it is 80 degree? That's what I have. That is the question. But I know a circle has a 360 degree. When it is 360 degree, I can find the circumference that by doing 2 pi radius. In this case, the radius is 4, right? So that's what I'm going to write. When it's 80 degree, I don't know what AB is, but I know when it is 360 degree, I can just simply do 2 pi r, which is going to give me the whole circle. So when you do the math, I like to leave everything in terms of pi, so that I'm not, dealing with rounding and is it perfect. So I try to leave it in terms of pi unless I have an equation that's already in decimal. Okay, so in this case, 2 times 4 is 8. 8 times 80 is 1600, so 160, right? Pi equals to 360 AB, right? That's what's going to be 2. I just want to make sure my calculation for the numbers are correct. So let's put it on this side so that you can kind of see both. Let's clear it up. So I'm multiplying 2 times 2, 4. 2 times 4 times 80. What did I get? 2 times 8. 640 is what I should have put done. Oh, I see the magic of calculator. I don't even know how I was thinking that way. Alright, so it's going to be 640. So I'm going to change that and fix it. So it's going to be 640 pi. This thing is really far. 640 pi. This is 64. And then I know AB times 360 is just 360. So I'm still need to find what is AB. So I'm going to divide both sides by 360. And I'm going to divide this by 360. Okay. So my thing is, I hate to touch the pi as it is. So I'm just going to leave it. So I'm going to do 640 divided by 360. Alright, 360. 360. And it might give me a decimal. Let's see if it's going to be a fraction. If not, then we'll just round it to the nearest. 16 over 9. Right? Did I put it the right way? 640. 2 times 4 times 80. So 16 over 9 pi would be the answer. So AB would be, right here would be, where is my cursor? It's hard to find this thing. Equals 16 over 9 pi. And if you want to multiply the whole thing, you can. Okay, so it's not a problem. Alright, let's do another example. It says find the value of x, y in degree. So the question now is, I don't know what the degree is, but I know the length of this xy is 18. So I'm kind of going back to this formula we just wrote down. So the missing part now is going to be the degree. So the measure degree is just going to be, you can write it as measure of xy. That's my degree. When it is 18 inches, when it is 360, I know it's going to be 2 pi, radius is going to be 7.64. So I'm going to do this all in a calculator and you guys can write it down, because writing in this laptop or in this tablet today has been very difficult, so you guys can do it. So what all I'm doing is, alright, where did it go? Alright, my tab. I want it to be whole page. Okay, here you go. Alright, so what I'm trying to do is cross multiply, right? So 16. Whew, this thing is not working for me today. So 18, so I'm going to say it out loud for you guys. Oh, it's already 15 minutes. Good. So 18 times 360 it gives you 6,480. Then I'm going to try to divide the whole thing by this number here, which is 2 pi times 7.6. So what I'm going to do is use a parentheses and put everything in just to um, save time, and not e, pi second pi times 7.64. Okay, then I close parentheses, and I'm looking for the degree, and the degree will be 134.999. So this would be 135 would be the answer. That's going to be the closest thing. Okay. All right. So I'm going to go to the next page, and it's asking for the same the same thing. It says find the radius of this circle. Okay. So still we're going to use the same formula, which is 2 pi r. Well, this thing is not working today for me. Getting frustrated, so probably this would be the last thing I'm gonna do. Then I'll do the rest in class with you guys. But I don't know. So this is what we got. So the degree in this case is 60, and I know the whole degree of a circle is 360 equals to the measure when it is 60 degree is 3.82, and the bottom one is 2 pi times radius, right? So that's what the formula we're going to be using. So all you have to do is just cross multiply it, okay? And I think you guys can cross multiply and solve for the radius as long as I set it up the equation. All right, the next one is a sector of a circle. So it's the same thing as finding area of a circle. So this is going to be pi radius squared, okay? Pi shaped section of a circle that included in center. Area of a circle is pi radius squared. So the sector is still going to be the same thing. The only difference is, if you guys remember here, uh, in the previous page, well, I jumped too many pages. When we did this, we said the measure of the arc over 360, AB over 2 pi r, right? Now, since I'm looking for the area, all I have to do is change it into pi radius squared. That's it. Everything is just going to be the same, okay? So I'm going to write, the formula would be measure of the arc, whatever degree it is, arc, whatever degree is, over 360 degree, equals to the area of the arc, okay? Area of the shaded region. Of the arc or the shaded region, sector, that's what we call it, over pi radius square is what I have to do, okay? So we will, and then you usually see it like, oh, this is shaded, right? This is shaded. What would be the area? So you can find the whole area and then kind of section it out. So the first question in this case is find the area of one slice of pizza. So this one is kind of easy, right? Because all you have to do is find the whole area and then divide it by 8. That's what a pizza slice is. So I don't know if you guys can kind of see it, but this dotted line is kind of the slice of the pizza. But it is 8 of them. And I know it's kind of hard to see it. I don't know if I'm looking at it from, in the dark. I don't know. All right, find the area of the highlighted sector. I believe this is the highlighted sector. So what I'm going to do is, okay, the degree is 45 over the whole thing, which is 360. I'm trying to find the sector of OCA, right, the whole thing, divided by pi radius squared, right? So that's going to be 64. So 64 times 45 times pi divided by 360. So since it's giving me a hard time to write today, and I know you guys don't want it to be more than 20 minutes, I'm going to end it here, but I'll finish in class, okay? But try to do it yourself first too.